Okay, so previously in this class we've talked about graphing linear equations. In this lesson we're going to graph linear inequalities. So our objective is to graph linear inequalities in two variables and to use linear inequalities when modeling real-world situations. So before we understand how to graph linear inequalities, we have to understand what a solution to a linear inequality looks like. So in example 1, I'm going to ask you to tell whether an ordered pair is a solution to a linear inequality. So in part A, for example 1, we have an inequality y is greater than x minus 3, and we're given a point, 1, 2. We want to see if that point is a solution. So it's understanding that 1 is the x value in that point, 2 is the y value of that point. So to test whether a point is a solution, we substitute 2 for y, so that becomes 2 is greater than x minus 3, which would turn into 1 minus 3. And we simplify both sides if we can. 1 minus 3 is negative 2. That inequality is true. So the point 1, 2, 1 comma 2 is a solution. It is a solution to that inequality. For the other point we are testing, negative 3 is x, negative 7 is y. So I would substitute negative 7 for y. This would become negative 7 is greater than, I'll do a better job at differentiating that. Negative 7 is greater than negative 3 minus 3. So negative 7 is greater than negative 6. That is false. So we would say negative 3, negative 7 is not a solution to that linear inequality. So what I'd like you guys to do is, in this guided practice, test the point 3, 6 in this inequality to tell whether it is a solution to y is less than or equal to 2/3 x plus 4. Give you a chance to pause the video, work through that, check your solution so you can move on to examples 3 and 4, or 2 and 3, sorry. Okay, so in this case, 3, 6 is a solution because when I substitute 6 for y and 3 for x, I get 6 is less than or equal to 6. So that is true. That inequality is true for the point 3, 6. So 3, 6 is a solution. Now in example 2, we are going to get some review graphing y equals mx plus b. So we have to remember in this equation it's y is less than or equal to 1/2 x plus 1. So in that equation, the slope is 1/2, the y-intercept is 1. So I'm going to start by graphing the y-intercept of 1. And I'm going to graph the point 1, 2. And I don't want you to draw a solid or dashed line. We are going to go through some examples and explain what each of the symbols mean. But when we graph linear inequalities, less than or equal to, greater than or equal to, is a solid line, okay? Just less than, just greater than, is a dashed line. And you will see some examples of this as we go through more examples. But since this is less than or equal to, I'm going to draw a solid line. And my line isn't super straight, but that's how I draw my line for y is less than or equal to 1/2 x plus 1. The thing I want us to understand is that we want our equations to be y equals every time. And we're going to talk about how to solve for them to be y equals. But for this inequality, since it's less than, I'm going to use the term shade below the line. And I'm going to use a different color to illustrate that. So with this line I drew, this would be above our line. This would be below our line. So what I'm going to do is I'm going to shade below this line. So if you have a pencil, just shade kind of lightly. You don't need to black out your entire side of your line, but this would be me shading below the line. The thing you can do to check to see that you shaded correctly is you can always substitute a number in that falls in your shaded region, because any point in this region I shaded in blue is a solution. So if I try 0, 0, let's just try 0, 0 as a point. If I substitute 0 in for x and 0 in for y, 0 is less than 1/2 times 0 plus 1. 0 is less than or equal to 1, so that number checks out, so I know I shaded in the right area. So I could pick any point from that area to tell whether it's a solution or not to that inequality. So in example 3, we cover some more specific instances of lines, and it's remembering that x is greater than -1, and I'm going to write out the thought process here, is that, first of all, x equals lines. Those are vertical lines, okay? Since this is just greater than, this is going to be a dashed line. So I want to take care of that first. -1, and I'm going to draw a vertical dashed line at x equals -1. Okay? Now, to shade this, you're going to think of numbers greater than -1 for x. So that means for this inequality, I'm going to shade to the right. I'm going to shade all the numbers that are greater than -1 as x values. So I'm going to say shade right, okay? In the next example, y is greater than or equal to 2. That's going to be a horizontal line. Since it's greater than or equal to, that line will be solid. And I'm going to draw that first. Horizontal line at y equals 2. That is solid. And it's greater than again. So in this case, I would shade above the line. Above the line. So that would be up here. This is above the line. So that's a harder thing to keep straight because you're talking about lines that are vertical or horizontal. But you just have to have a good understanding of greater than or less than. So above or below can get a little tough. That's why we're going to practice this. Moving ahead, there's some more guided practice and then an application problem. So I'd like you to try the guided practice. Try to remember y equals mx plus b form. I'm going to graph each of these. Try to at least graph the line. Maybe don't shade yet, and then just see how I shade the lines. Just graph the lines right now. And then once you're ready, resume the video and see how I shade to help you kind of understand, because erasing, if you shade the wrong way, is going to be tough to do. Okay, so those are my graphs, and just to explain real quick, in example 3, or in part 3, I had a y-intercept of -2, a slope of 1, so I drew that line, and it's a dashed line because it's just less than, and I shade below. The thing I want you to understand is the reason this is dashed is because the line is not part of the solutions. So any point on the line is not a solution to this inequality. That's why it's dashed. So that's me shading below. For number 4, it's a vertical line. It's also dashed, and it's less than. So for a vertical line, I would shade to the left. Number is less than -5. So that's -6, -7, so on. For number 5, horizontal line, solid line, because it's less than or equal to, and I would shade below because it is less than. So we'll get some more exposure to problems like this, but I want to at last cover an example, okay? An example of an application of this. So it says, for a party, you can spend no more than $12 on nuts, and peanuts cost $2 a pound, cashews cost $4 a pound. What are 3 possible combinations of peanuts and cashews you can buy? So, to show an inequality for this, we're going to have x and y. X is going to be peanuts. Y is going to be cashews. So the inequality that represents my cost is, my cost of peanuts is 2 pounds, or $2 a pound for peanuts, times the number of pounds of peanuts, plus $4 a pound for cashews, times y pounds of cashews. And if I can spend no more than $12, it's going to be less than or equal to 12. The problem with this inequality is that it is not y equals. So I want to walk you through the steps, and it's important that you write out each of the steps to solve for y. So to solve for y, to get this into y equals mx plus b form, slope-intercept form, I'm going to subtract 2x first from both sides. So this becomes 4y is less than or equal to -2x plus 12. And then my final step is to divide both sides by 4. And that means divide everything by 4. So my new inequality in slope-intercept form to make it easier to graph, is y is less than or equal to negative 1/2 x plus 3. Okay? So that's an example of how to solve for y when y isn't isolated. So to graph this, a y-intercept of 3, a slope of negative 1/2, which means I go down 1, right 2, down 1, right 2, down 1, right 2. And this inequality is constrained to positive x and y values because positive pounds of peanuts, positive pounds of cashews. So to shade this, any point inside of this little triangle I drew and shaded would be combinations. So combinations of cashews and peanuts I can buy, I asked for three possible combinations. So I could say 0 pounds of peanuts, 3 pounds of cashews. That's a possibility, right? So that's this point right here on the y-axis. I could do 1 pound of peanuts, 1 pound of cashews. That would be this point. Or I could do 3 pounds of peanuts and still 1 pound of cashews. Those would all be within my budget, okay? So inequalities can represent things like budgets because you have a limit that you can't go over. You can hit that limit, you can be on that line, or you can be under that line to fit inside of that budget. So example 5, I do want to save to cover in person. So if you do not do example 5, that's okay right now. I'm going to save those practice problems too because I want to explain that more in person. I may post a separate video for example 5, but I think that this is enough to practice just for day 1 of this lesson, examples 1 through 4. So you can move on to the next step of the lesson. Make sure you're taking your time. Pause the video, go back if there's anything that kind of isn't cleared up, and I can answer those questions if you need me to. So you can move on to the next part of this lesson.